We are to find the resultant of the system of forces shown here. In this video, we are looking at the resultant of more than two vectors. So if you look at this picture or this system of forces, you will find out that we have more than two forces and we have to find the resultant. To find the resultant, we simply resolve each of these forces to their horizontal and vertical component. Then we add up all the horizontal components and add up all the vertical components to form a system of a single vertical and a single horizontal force, and then we can find the resultant. It is very simple. What we are going to do first is to make it clear that the forces to the left are going to be negative, while forces to the right are positive. In other words, when we resolve the horizontal component, the forces that will be going towards the right will be treated as positive, while the forces to the left will be treated as negative. Similarly, downward forces will be treated as negative for the vertical or vertical component, while upward forces will be treated as positive for the vertical component. So now we are just going to resolve each of these forces to the horizontal and vertical component, and we'll add them up at the same time. So first, let's start with the horizontal component, beginning with the force of 10 Newton. 10 Newton is already in the horizontal and is to the right, so it's going to be positive. So the sum of the horizontal forces, Fx, is equals to 10. So we have 10 to the right. Now let's move to the second force, 12 Newton. 12 Newton is at an angle of 50 degrees to the horizontal. If we resolve 12 Newton to the horizontal, we have adjacent over hypotenuse, and that is cos. So that becomes plus 12 cos 50. It is positive because the horizontal component of this 12 Newton force will be acting to the right, and we said forces to the right are positive. That's why I have positive 12 cos 50. The next force is 20 Newton. The 20 Newton force is acting in this direction, so its horizontal component is to the left, so it will be negative, and that is also adjacent over hypotenuse. So we have minus 20 cos 40 because the horizontal force or the horizontal component is in the direction to the left. Now let's look at 16 Newton. The 16 Newton force is vertical, so it has no value to the horizontal. So we are going to omit it. Or if you want to solve for it, the angle this force makes with the horizontal is 90 degrees. So 16 cos 90 degrees will give us 0 because cos 90 is 0. That's why we ignore the 16. Then we'll move next to the force of 15 Newton. The force of 15 Newton makes 30 degrees to the vertical, so to the horizontal it will be 60 degrees. If this is 30, then this angle is 60. The horizontal force is to the right, so it will be positive, and that is cos adjacent over hypotenuse. So we have plus 15 cos 60. The angle here is 60, and it is to the right, the horizontal component, so it is positive, and it is adjacent over hypotenuse, and that's why it is cos. So if we put these values in the calculator, we have that the horizontal component of the force is equals to 10 plus 12 cos 50 is 7.71 minus 20 cos 40 is 15.32 plus 15 cos 60 is 7.5. If we add these values, we are going to get Fx is equals to 9.89 Newton. We are done with the horizontal components. Let's look at the vertical component. The vertical component Fy is equals to, if you look at this force of 10 Newton, it is horizontal. It has no value to the vertical. So we are going to omit it, or if you want to write it, you do 10 sine 0. Sine 0 is 0, so this disappears because it has no effect in the vertical component. So we omit 10 and we'll go to 12. To the vertical, we have this is the vertical, and that is opposite side of the triangle. Opposite of hypotenuse is sine, so this becomes 12 sine 50. It is positive because the vertical component is in the direction upward, and upward forces are positive. For the 20 Newton force, the vertical component is also upward, so it's going to be positive. So we have positive 20 sine 40. This is already downward, and it is 16, so it is negative 16. And for the one of 15 Newton, it is also downward. The vertical component will be downward, so it is negative. So we have 15 minus 15 sine 60. Sine 60, because the angle here is 60 degrees. If this is 30, then this is 60. All the angles we've considered are the angles the force made with the horizontal. But the 30 was made with the vertical, so that's why we have to subtract it from 90 to get the angle that this force of 15 Newton makes with the horizontal, this angle here. So if we put these values in the calculator, we have that Fy is equals to 9.19 plus 12.86 for 20 sine 40 is 12.86 minus 16. 15 sine 60 is 12.99 minus 12.99. If you add this together, it gives you minus 6.94 Newton. So these are the forces we have. The horizontal force 9.98 Newton. The vertical force is minus 6.94 Newton. So let's draw this in the vertical and horizontal direction only. So we have the horizontal force 9.89 Newton. It is positive, so we drew it to the right. This is negative, so we drew it downward, 6.94. And this becomes the resultant arrow that we are looking for. Of course, we can use Pythagoras theorem here because this is a right angle triangle. If we close this side, 6.94 is also 6.94. So definitely we have that r square is equals to 6.94 square plus 9.89 square. Pythagoras theorem. R square is equals to 145.98. This square plus this square gives us 145.98. To obtain r, we take the square root. So r is equals to the square root of 145.98. We took only the positive value of r because forces are not negative. That is why we have omitted the plus or minus sign. So we are taking only the positive and we've discarded the negative because forces are not negative. They are always positive values. We are looking for the absolute values of the force here, of the resultant force, because we have already taken account of the direction in drawing this force. We have omitted the negative. So that R is equals to 12.08 Newton, which is approximately 12 Newton. So this is the resultant force of the system of forces we drew, or we show that we have shown previously. Now that you understood this, please try this simple one. Find the resultant force of this system of forces shown here. Put your answer in the comment section. Thank you very much for watching this video. Please like, share, drop your comments, and I will be in the comment section to answer your questions if there are any questions. Thank you for watching.